So we are going to discuss the solutions of the system of linear equation. And the system, there is very important thing that we want to see. Sometimes the system has the solution and sometimes the system doesn't have the solution. When system has the solution, we say it's consistent. And if system doesn't have the solution, we say inconsistent. I explained you with the help of example. We take very small example for this one. That we want to solve the system of linear equations. Very small example I'm going to take this here, the x minus 3y equal to minus 3. And then I have the equation 2x plus y is equal to 8. This is my equation 1 and this is my equation 2. I want to find the solution. So in this example, I just want to show you that there is a solution, there is no solution. Here, we want to solve just simply. We multiply here by minus 2, add to this one, we say minus 2e1 plus e2. Multiply by minus 2, we get minus 2x plus 6y is equal to 6. And we add this one, this is e2, that's 2x plus y is equal to 8. When we add it, this is cancelled, then we get here 7y is equal to 14, and give the value of y equal to 2. So I can substitute the value of y in any one of the equations. I will get the value of x. I substitute in equation 1. So we get here x minus 3 into 2 is equal to minus 3. Again, take here x minus 6 is equal to minus 3. I get here x is equal to minus 3 plus 6 is equal to 3. So I get the solution. My solution is solution of the system which I got here, the value of x and y. My x is equal to 3 and y is equal to 2. So one more way of looking at this one, if I write the equation of, if I take the graph of the equation, then this point is coming on both of the equations. This is my example 1. So we have the system has the solution. So I take another example where we see that the system will not have the solution. The example is example 2. So we take here the system of equation as x minus 3y is equal to minus 7. And my second equation is 2x minus 6y is equal to 7. So here is my equation 1. And here is my equation 2. Again, we eliminate our x. To eliminate x, we just multiply the first equation by minus 2 and add to the second equation. So we have minus 2e1 plus e2. So multiply minus 2, I get here minus 2x plus 6y is equal to 14. I get here 2x minus 6y is my equation 2, 7. I add it. This cancel, we get here 0. Again, here we get here 0. And here we get here 21. Now we can say our 0 is never equal to 21. So we say there is no solution. There is no solution. So as I said, in example 1, we have the solution. This was our solution. And here there is no solution. So from the solutions point of view, we just try to develop a word. We say consistent. Consistent. We say system is consistent, means it has a solution. And the second one, we say inconsistent. Inconsistent, means having no solution. So we can develop an example where we can find there are many solutions. It can have there is no solution, there is one solution, and there are many solutions. In this example, I'm going to show you that the system will have many solutions. We take here x minus 2y equal to 3. I get here 2x minus 4y equal to 6. I want to solve this equation. This is my equation 1, and this is my equation 2. I just multiply equation 1 by minus 2 and add to equation 1 by minus 2 and add to equation 2. I get here minus 2x plus 4y is equal to minus 6, and I get here 2x minus 4y equal to 6. Add it, I get here 0 equal to 0. So if it's 0 is equal to 21, the last example, left hand side is, right hand side is not 0, left hand side 0, there is no solution. Here you have many solutions, and these solutions are coming from any one of the equation. I take equation 1, this is my x minus 2y equal to 3. So I write my x is equal to 2y plus 3. So for each value of y, we have the value of x. So if, for example, I take here the value of y equal to -1, here is the value of y, we take it -1, so I get the value of x. I put here -1, I get here 4, so my value of x is equal to -2 plus 3 is equal to 1. I take x, y equal to 0, I take y equal to 0, I get the value of x equal to 3. I take the value of y equal to 1, so get the value of x is equal to 5. So I just draw this graph for this one. This is my xy plane, this is my x-axis, and this is my y-axis. I have taken the point for x. For x is 1, 3, and 5. This is my 1, this is my 3, and this is my 5. So I get the value of y. Value of y for 1 is -1. This here is -1. And for 3 it is 0. For 3 the value of y is 0. This is value of y is 0. And then I have for 5 the value of y is 1. So I get the point here, this one point, the second point, and there is the third point. These points are on the line. They are lying on the line. So this is the equation of line E1, and this is also going to represent the equation of line E2. So here this same equation is going to represent the equation E2, and these points are on these equations. So this is my E2, and here is my E1. So we say each point on the line is solution of my system of equation and having many solutions. So as I've shown you, we having system is two type. When it's having system system has one solution or many solutions, then we say system is consistent. We say here system is consistent. It has many solutions. I will say here, we say at least one solution. At least one solution. That means the same. One solution or many solutions. So this is number one. And number two is we say the system has no solution. System has no solution. So when the system has no solution, we say system is inconsistent. System is inconsistent. So that's the idea for the system to be consistent, is at least one solution. System is inconsistent, having no solution. Now we are going to discuss the methods for solving the system of linear equations. So we have already discussed that we use the elementary row operation for solving system of equation, and there are three operations. Number one, we can interchange two rows. Number two, we multiply row with a non-zero real number. Number three, we add multiple of a row to another. In this way, these are the operations we use to solve the system of linear equations. So as we discussed before in the last video, that we can write the linear system in the form equation form. This is my form, we say in equation form. And we are having very important form that we just describe, that we can write a system in that form and we can make the operation. We call it augmented matrix form. Augmented matrix form. In augmented matrix, always we start from for the solving any system, writing the augmented matrix form. This our A is a matrix of the coefficients, our X is matrix of unknown, and our B, this one is matrix of the constants. So we take here only the data. That's my A is my matrix of the coefficients, B the matrix of constant. We can just write this one. Here we get A11, A12, A13, this is my A, A21 first row, and this is my second equation. That becomes second row, and my third equation become my third row, and this is my matrix A. And here I take a line to separate this one from the matrix of the constant, B1, B2, B3, and I always mention this one as my row 1 of the matrix, this row 2 of the matrix, and row 3 of the matrix. So this is my augmented matrix form. And here we go to our new discussion that we discuss two methods. Method 1 is our Gaussian elimination method. Gaussian elimination method. In Gaussian elimination method, this is our matrix, which is the argument matrix. We change this matrix to this form. I make the row operations, and with the help of row operation, I try to achieve this one. This here 1. This is my new coefficient, and this is my another new coefficient, and then this is my 0, and here it is 1, and I get here A 2 3. I get here 0 0 1. So as I reduce this one by row operations, my B is also changed, and I get here this as B1, B2, B3. We just write, we solve it with the help of row operation, and we try to make this one as Gauss elimination method. These are having here 1. This entry may be 1, may not be 1. But when we're going to discuss further, that's our row echelon form. There we need to get it 1. These pivot values in Gauss elimination method, 1 may not be 1, but it's better to take it as 1 because that helps us to make the operations more correctly and quickly. So I can give you the example, and we'll show you how this Gauss elimination method is working.